In this video, we will learn how to compare fractions to benchmarks 0, 1/2, and 1 whole. So what is a benchmark? Why is 0 called a benchmark? Why is 1/2 called a benchmark? And why is 1 whole a benchmark? A benchmark just means it is a really common number. Since it is such a common number, it is easy for us to use that number when we compare fractions. We can measure or judge against these benchmarks when we're trying to compare numbers. Today we're going to look at fractions and see how they compare to the benchmarks. So for example, if I have a fraction right here on the number line, I can compare it to the benchmark of 0 and the benchmark of 1/2. I can ask myself, is this fraction closer to 0 or is this fraction closer to 1/2? And we can see that it's closer to 0. If I have a fraction that falls right here on the number line, I can compare it to the benchmark of 1/2 and to the benchmark of 1 whole. I can ask myself, is this fraction closer to 1/2 or is it closer to 1 whole? I can see that it is just a little bit closer to 1 whole. Using benchmarks help us think about the size of the fractions and really understand how small or how big they are. Let's get started. Number 1 asks, is 2/6 closer to 0, 1/2, or a whole? So I'm going to use the number line to help me decide my answer. We'll go ahead and start with 0 and put a whole. And then I'll put 1/2 right in the middle. And then I'm ready to put 6ths. I know that that whole needs to be split up into 6 pieces. In fact, I'll go ahead and write down 6/6 equals a whole. I know that at the halfway point, that's 3/6. I need to have 3 pieces on this side and 3 pieces on this side. We have 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. So now we're ready to compare 2/6 to 0, to 1/2, and to the whole. I'm really looking at those distances, so I'm going to draw jumps. If I look at the distances, I can see that the distance between 2/6 and 3/6 is the least amount. It's the smallest jump, which means 2/6 is closer to 3/6 or 1/2. So that's my answer. And now I'm ready to go ahead and answer these questions. 2/6 is blank away from 0. Well, I can see that it's 2 pieces. It's 2/6 away from 0. How far is it away from 3/6 or the half? It's just one jump, one piece. So 1/6 away from a half. And then how far is it from 2/6 to 6/6? 1/6, 2/6, 3/6, 4/6 away. It's 4/6 away from a whole. And that's how you do number 2, number 3, number 4, number 5, number 6, even number 7 on the back. After you're finished with those problems, go ahead and watch the video again to see how to do number 8. So the first thing I notice when I look at number 8 is that there is a denominator of 100. The question asks, is 21/100ths closer to 0, 1/2, or a whole? So don't worry, we're not going to put 100 little tick marks on our number line, but we are still going to plot about where we think it is. We can still put 0 on the number line and a whole, and then we can put our halfway point. Now we need to think about hundredths. We know that 100 hundredths equals a whole, so I'll go ahead and write that underneath. 100 hundredths. What fraction is equal to 1/2 that has a denominator of 100? What is half of 100? We've talked about that a few times. I'm liking money. If I have 100 pennies or $1, what is half a dollar worth? How many pennies make up half a dollar? $50 pennies is worth 50 cents. 50 hundredths is at the halfway point. Now I need to think about where 21 hundredths falls on the number line. We know that 21 is a smaller number than 50, and so this would be 21 pieces versus 50 pieces. So 21 pieces is somewhere between 0 and 1/2. It's not going to be on this part of the number line. Since we're thinking a little bit about money, we can also think about quarters. We know that 4 quarters makes $1. If you have 1 quarter, how many cents do you have? We know that 4 quarters equal $1, and so I could show 4 sections or 4 pieces. So this would be a quarter, this would be a quarter, this would be worth a quarter, this would be worth a quarter. If you have 1 quarter, how many cents do you have? 25. So we could say that this point on the number line is 25 hundredths. 2 quarters is worth 50 hundredths. If you have 3 quarters, that means you have 25 cents plus 25 cents plus 25 more cents. You have 75 cents. So 75 hundredths. Now that we have quarters on the number line, we can estimate where 21 hundredths is. 21 pieces is less than 25 pieces, or 21 cents is less than 25 cents. So I know that it's going to be somewhere around here. Just a little bit less than 25 hundredths. I'll go ahead and write it up here since I'm out of room down below. And then I can easily see if it's closest to 0, if it's closer to 1/2, or if it's closer to the whole. Now that's one way of thinking about it. One other way that I could think about it is to think about tenths. So we know 50 hundredths is in the middle, and we know that it's pretty easy to count by tens to get to 100, and this also goes along with dimes. So just counting by tens, we'd have 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I can make 5 sections on this side and 5 sections on this side. So this would be 10 hundredths, 20 hundredths, 30 hundredths, 40 hundredths, 50 hundredths, 60 hundredths, 70 hundredths, 80 hundredths, and 90 hundredths. All right, then we can be really pretty confident about where 21 hundredths is. 21 is just 1 piece after 20 hundredths. So we know that would be about right here. Okay, and then we can still look back at 0. We can look at where the halfway point is. And then we can see how far away it is to the whole. So I'm going to go ahead and put these side by side so we can look at them together. You can pick whichever way makes the most sense to you. If I look at the distances, I can tell with both number lines that 21 hundredths is closer to 0 than it is 1/2. and that shows on both number lines. So my answer is 0. So I'm going to think about 21 hundredths compared to 0. I can see that it's 21 hundredths away from 0. If I'm going from 21 to 50, I can think about going the distance from 21 to 25, which is 4, and then 25 more would take me to 50. So 4 plus 25, that's a jump of 29. So 29 hundredths away from the half. And then I know that from 50 hundredths to 100 hundredths, that's a distance of 50 hundredths. So I'm jumping 29 hundredths to get to the halfway point, and then I'm jumping another 50 hundredths to get to the whole. So 29 plus 50 is 79. So 79 hundredths away from the whole. So on this number line, it's the same answers. 21 hundredths away from 0. We still have to jump from 21 to 50. We have the distance from 21 hundredths to 30 hundredths. That's 9 pieces. From 30 to 40, that's 10 more pieces. And then from 40 to 50, that's 10 more pieces. So we have 9 hundredths plus 10 hundredths plus 10 hundredths. That's 29 hundredths away from the half. We can do this part in one jump. 51 hundredths to 100 100ths. That's a jump of 50 hundredths. So we have 29 hundredths, 50 hundredths. That's a total of 79 hundredths.